So the other day we looked at roots as exponents, and roots show up as fractions or the denominator in an exponent. But what about zero and negative exponents? What does a zero exponent mean, and what does a negative exponent mean? So let's take a look at some patterns here. So I've just looked at powers of 3. So if I have 3 to the power 4, I get 81. So 3 times 3 times 3 times 3 is 81. 3 to the power 3 is 27. 3 squared is 9. And 3 to the power 1 is 3. Now, if we just kind of continue this pattern, we're just multiplying by 1 less 3, 1 less 3, 1 less 3. And if we're multiplying by 1 less 3, essentially we are dividing by 3. Dividing by 3. Dividing by 3. So if I do 1 less multiplication of 3, again, that would mean I'm dividing by 3. And that means that 3 to the power 0 must be equal to 1. So a zero exponent looks like 3 to the power 0 is equal to 1. And really I didn't have to be base 3, I could use any base. Okay, I could say that a to the power 4, okay, is going to be using a 4 times. So I divide by a, I get rid of an a, divide by a, divide by a. And if I divide a divided by a, I get a to the power 0, and a divided by a must be equal to 1. And really what ends up happening is, if we can generalize this for any a, that means that for any base, a to the power 0 must be equal to 1. So any power of 0 then we define as equal to 1. And we can get there by using this division. Now if we can get to 0, that means that we can just keep going and we can take away one more exponent and we end up with negative 1 exponent. Well, what does negative 1 exponent mean? Well, if I continue the pattern down here, if I divide by 3 one more time, I'm going to end up with 1/3. So that means I'm dividing by 3 once. And if I do another, take away one more exponent, do one less multiplication, I can divide by 3 again. And that means I have divide by 9, or 3 squared. And if I do it again, if I divide by 3 again, well, I'm going to take away one more exponent. Well, dividing by 3 3 times is going to be 3 in the denominator, or 3 cubed in the denominator. And we can then keep generalizing this. Okay, if we're going to multiply in one direction, we can divide in the opposite direction. And what ends up happening then is that negative, really all that's doing is, once I get to 1, I'm now dividing. The more negative I get, the more often I'm dividing. So in essence, the negative counts the number of divisions. I'm dividing by 3 once. I'm dividing by 3 twice. I'm dividing by 3 3 times. And I can generalize this for any exponent. So if or positive exponent is repeated multiplication, that means decreasing the exponent must be the opposite, which is repeated division. Or the negative exponent counts the number of divides. The positive exponent counts the number of multiplies. And the zero exponent basically comes from when we subtract the powers. Okay? If we have 3 to the power 5 divided by 3 to the power 5, that means we take away 5 times from divide. That gives us 0 times in divides. Well, 0 times in divides really means that, well, this divided by this is the same number divided by the same number gives us 1. So that means that 3 to the power 0 is equal to 1, or anything to the power 0 is equal to 1. And we can justify it with this subtraction rule. We can just justify this by going backwards, by dividing and seeing what happens if I divide these numbers, okay, by the base. Any way we do it, we end up with any power of 0 is equal to 1. So the 0 exponent is always equal to 1.